if we have a equation that either begins looking like this, or we can put into this form, where you got x minus h squared over a squared plus y minus k squared over b squared equals 1. Yeah, that is hopefully obviously related to we talked about this last time, x squared over a squared plus y squared over b squared equals 1. That's an ellipse. This is an ellipse because it's very much like that, except I've got something subtracted, if you will, from that x and from the y. And so that's going to just shift it. So this is just an ellipse that's been shifted HK, right? And so basically what that it puts the center at HK. So this is an ellipse with center HK. Just like the circle, we do the center HK. Ellipses, same deal, so good news on that. Whatever you subtract from that H, X is your X value of the center, and then whatever you subtract from the Y is your Y value of your center. So basically the same thing. It's, you know, it's a little more complicated because you got the format for the ellipses. You want one side equals 1 because that tells you how far out to go in both directions and that sort of thing. And now the other consideration is, remember on the ellipses we want the a squared greater than, well, the a squared greater than b squared, but a greater than b because of the foci. The foci still will be same formula to get the foci. C squared equals a squared minus b squared. So that's the same formula as the non-shifted ellipse. That doesn't change, but because you want the a squared bigger than the b squared, sometimes they'll also say, well, you could have this where the b squared is under the a squared, but that's just because you want the a bigger than the b. So that's why they usually sometimes write this in two different ways you can do it, but that's the way they choose to do it here. But yeah, so let's just do a couple here. All right, so let's say we've got x plus 2 squared over 9. Oh, sorry. I'm doing the hyperbola I was going to do. It's x minus 3 squared over 25 plus y plus 4 squared over 36 equals 1. Yeah, and so that's in our ellipse format, if you will, because you've got the x squared plus the y squared, it equals 1, that sort of thing. That's the way we recognize that. Now what's the center here? Well, the center, just like the circle, we read the center off of these numbers inside the parentheses. The center, the x coordinate of the center comes from that. Positive or negative 3?
3.
Positive 3, yeah. You do the opposite. Same thing here. The y value comes off of this value. Negative 4, do the opposite. That's going to be the center, just like we did circles. Okay? All right, so if I try to graph this thing then, here's what I've got. Let's just go over here. So we go out to 3 and negative 4. from the center. Well, if you remember, when we graphed the ellipses before, what we did then is we went out in the x direction, the y direction, the appropriate amount. Well, what was the appropriate amount? Well, under the x, if you will, here, I've got 25. And so remember, in the x direction, then you go out the square root of that. 5 there. Now, since our center is shifted, we go out 5 units, not along the x-axis, but to the right and left of the center, just like we did with the circle and the radius there. So I'm going to go out 5 units, right and left, from the center. So 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. So we're under the -2 here. That's where that one would be. And that's how far I would go out in the x direction, but it's right and left direction. It's not on the x-axis, if you will. With me there? All right, then the same thing, do the same thing in the y. With the y here, what's underneath the y? Square root that, and that tells you how much to go up and down. 6 units up and down. 1, 2, 3, 4, 5, 6. I'll be up here at 2. And then 1, 2, 4, 5, 6. What would that put me at? -4, -10. Down here, -10. Right under. So 6 units up and down from that center. All right, then connect them into an ellipse here. You got your graph. All right, now, we did a couple of other, that will want us to identify a couple of other features, if you will. One of them is the vertices, which is just plural for vertex. Remember what, on the ellipse, which ones are the vertices?
The ones on the longer axis.
The ones on the major axis or the longer axis, right. It's the endpoints of the major axis, the longer axis. Which, by axis, what we mean is through the center, up and down, right and left. Yeah, the longer one here is the vertical one, right? This would be the major axis because it's longer. This would be 12. This is 10, right? So those endpoints, the vertices here, are this and then that. Okay?
So we'd write that as like 3-2 and then 3-10.
Yeah, so you've got the x coordinate is, of course, 3 for that point and that point too. But let's start with this one. So yeah, that point is 3, 2.
And then 3-10.
And then the point down here, 3, -10. The other two, they're not given a special name. They're just endpoints of the minor axis and the shorter axis. But the other one is, the other two, the other feature,
Okay.
the foci, yeah. And that's where I erased it, but use that formula. C squared equals a squared minus b squared. And the only catch is the a squared needs to be the bigger one, of course. So it would be 30, this would be the a squared, this would be the b squared, 36 minus 25. So that would be c squared equals 11. So c would be the square root of 11, plus or minus. Additionally, I guess it's just plus, but which is about, so we can locate them here. 3.3? 3.3. And again, where are those located? It's on the major axis, right? So again, these will go along the ellipses. The foci are on the major axis. It's on the major axis. So I'd go 3.3, which way? Up and down, right? So 1, 2, 3.3. There's one foci. And then 1, 2, 3.3. So there's another foci. So can we get coordinates for that? A little harder, I guess, but here's the thing. Both of those are going to have the foci here. The x value is 3. I just got to figure out the y value. Well, if I go 1, 2, 3.3 from that, let me just tell you. All right. So my center is -4, right? 3, -4. And so what I'm doing is I'm adding and subtracting this from the y value. So one way I could do this is say, well, the y coordinate of the foci, what I need to do is add or subtract that square root of 11 to that, or the 3.3, and that might help you get the values there. Because that's what I'm doing. I'm adding and subtracting the 3.3 to get about 3.3 to get those. So we want to be a little more specific. Let's see, so -4 plus 3.3, that's going to be
-7. Oh, you're
-0.7.
7.3 if you're doing the bottom one.
Oh, you did that.
I did it backwards.
7.7. And then -3 plus the -4 plus the 3.3. Yeah, -0.7.
Is it positive 3 or negative?
Oh, positive 3. We know the x coordinate is positive 3. So this right here was -4 minus the 3.3, and this was -4 minus plus 3.3. Do it backwards. All right. Anyway, you can figure those out. One other one I would mention on here on the conics, let's say I've got all right, so let's say I've got 9x, let's just do 9. It's really strange. 9x squared plus y minus 2 squared equals, let's do it this way. X squared plus 9 times y minus 2 squared equals 36. Do that. X squared plus 9 times y minus 2 squared equals 36. I don't know if there's one you have to do like this, but it's good to think about. All right. Now, this one is not quite a circle. Really, a circle is just really a special ellipse. If you think about it, a circle is where you go out the same in both directions. So it's really an ellipse that has the same dimensions, if you will, both directions or in all directions. But this one's not a circle because of the 9 here. So if you have a number, usually if you have a number in front of your y squared or x squared, that means it's not going to be a circle, unless they're both the same. But yeah, this one's going to be an ellipse because of the 9 here. Now, since it's an ellipse, I need it, what, side to be what? One side to be what? 1, yeah. To figure this thing out nicely anyway, I need one side to be 1 for an ellipse. And so first step here, divide by 36. And both sides by 36. Which means basically I'm going to divide everything by 36. And so if I simplify this side, it'll be x squared over 36 plus, what happens here? Cancellation? Mm-hmm. The 9 goes into 36, so that leaves me y minus 2 squared over 4. equals 1. And so yeah, that makes it hopefully clear there that that's an ellipse. Center, where's my center?
0, 2.
0, 2.
Yeah, there's no, there's nothing subtracted from the x, and so that means the center x value would be 0, but the y is shifted, if you will, and it's 2 units. So 0, 2, the center? Yes? Okay. All right, and so graph-wise, 0, 2 is my center. Oops, I usually put an X for the center, just to make it, it's not an actual point on the graph, it's just a reference place. So that's my center right there. And all right, so I've got x squared over 36, so I go out in the x direction, 6 backwards and forwards, so 1, 2, 3, 4, 6, and then 1, 2, 3, 4, 6. The other direction to the left there, and then in the y direction, the square root of 4, 2 in the y direction, up and down. Yeah, so we got this nice little elongated ellipse there. Now the vertices here, where would those be? The longer one, so it'd be here and here. So what is that? Oh, those are pretty nice. 6 and negative 6, 0. Not 0, but 2. That's negative 6, 2, and that's positive 6, 2. And then you can figure out your foci. Foci from that, do I do that? So the foci here, we've got c squared equals a squared minus b squared. And again, this one's reverse of the last one because the a squared is the bigger one. So in this case, the a squared is under the x squared. The a squared is 36 minus the b squared 4. And so c squared would be 32. C would be that square root of 32, which that's about 5.4?
5.6.
5.6, 5.65, yeah. 6. Let's call it 5.7, since it's a 5 at the next one. All right, and yeah, so then again, those are on the longer axis, so that would be 5 units from the, 5.7 units from the center. So they're pretty close to the vertices in this case. They're a little easier to figure out. It would just be negative 5.7, 2, plus or minus, I guess. In this case, we could do that. It's the x value is 0. But anyway, just have to make the adjustments for the shift. All right? Okay, well, good news on the hyperbolas is shifting's the same. All right, so if I've got x minus h squared over a squared minus y minus k squared over b squared equals 1, because it's x squared, y squared, but it's minus in between. Yeah, that's a hyperbola centered at 0, hk. Yeah, same thing. Whatever subtracted from the x is your h, whatever subtracted from the k is your y value, your center. So that's good. Shifting works much the same way. Now, for the foci, well, we use that formula I used. C squared equals It's a squared plus b squared, isn't it? So again, that's good news. That formula doesn't change. You still do a squared plus b squared to get the c squared. And then square root that to get that c distance. That's the distance to the foci. All right, now, the only other thing we need to talk about here is we have two types of hyperbolas, don't we? We've got the right and left branch, and we have the upper and lower branch. Which one is this? This is the right left, yeah. Yeah, it's because the x squared is first, right? The x squared is first minus then the y squared. That's a right and left branching hyperbola. And so if it's y first, minus x minus h squared over b squared equals 1. And here, on the hyperbolas, the a squared and the b squared, it doesn't really matter which one you call which because of the formula for the foci. Basically, you're adding them anyway, so you don't have to really account for which one's bigger, but it all works out. But the thing, notice here, please be aware, is notice I still put y minus k squared, x minus h squared, because the hk, you still have to get the h from the x and the k from the y, you know what I'm saying? And so on the equation, they're switched around as far, we do hk. Well, the k here, the h is here, all right? So that's the only thing you really have to pay attention to. So that's a hyperbola. hk is the center. With, and since the y squared is first, the x squared is behind the minus sign, that's upper and lower branches. Okay? So a couple of considerations there. All right, so let's try a couple of those. All right, so x plus 2 squared over 9 minus y plus 1 squared over 36 equals 1. So yeah, we got the x squared minus y squared thing, so that's a hyperbola. The x squared is first, so we've got right and left branches. And my center is going to be shifted, so I need to note the center here. Well, the center, we go the opposite, right? X plus 2, so the h would be negative 2. And it's y plus 1, so the k would be negative 1. So this graph looks like this. Negative 2, negative 1. I need there, but we'll expand it if we need it. All right, so the center is negative 2, negative 1, so that's right here. That's my center. Now remember, graphing these, we still go out the same thing we do in the x. We would go out the square root of 9, which is 3. So from the center, we go out 3, backwards and forwards. So 1, 2, 3. And then 1, 2, 3. And put a mark there. And then square root that 36 to get 6, and that's under the y, so that's how much we go up and down, 6, or negative 6, if you will. So 1, 2, 3, 4, 5, 1, 6. I'll need a couple more on this one. 1, 2, 3, 4, 5, 6. But it's not an ellipse. So I connect those. The way I do that is with a rectangle, fundamental rectangle. Spin those out that way, these up and down. So yeah, we get this little rectangular reference box, or whatever you want to call it, fundamental rectangle. And what that gives me for the hyperbola is the asymptotes. So the asymptotes then draw the diagonals through the center and those corners. Extend it on out there. Now we can draw our hyperbola. Since it's right-left branches, I go to the right and the left. Like I said, these are asymptotes. So I want to, that just means they get closer and closer to those the further out you get. So it kind of comes in like this, and then it hits this point right here. That's going to be a vertex, and then it goes out similarly on the other side, and then the right one does the same thing. Hit this as your vertex right there. Yeah, that's my vertices there. So the let's see, that would be +1, comma, -1. And then that one is 1, 2, 3, 4, 5, -1. -5, -1. So the vertices are these points here. Yes? And then the foci, same thing as we did with the ellipse. The foci are c² equals a² plus b². So we're just going to add these two. 9 plus 36. On the hyperbolas, doesn't matter which one's bigger because you're adding them. So that's 45.
Square root is 6.7.
Square root of 45, 6.7?
Yep.
Approximately. And again, where are those located? Well, they're 6.7 from the center, and they're just right outside the foci, if you will. However you want to phrase that. So we go 6.1, 2, 3, 4, 5, 6.7 this way, and then 1, 2, 3, 4, 5, 6.7 this way. I believe that's right. So a little 0.7 more from that, which is where are we at there? That's maybe 2. Yeah. So it's a little past -8. That's 1, 2, 3, 4, 5. It's just a little inside the 5 on the X there. Yeah, but the actual coordinates there to get those, see the center is -2, -1. The y value of both of those, both sides obviously -1. And to the -2, you just add and subtract the 6.7 for the foci. To get this. So, whichever way you go out, that's, you add or subtract the foci to get the C value. Or you can look at the graph and figure it out that way too. All right, so what's that going to give? -8.7, -1, and then -2 plus 6.7, what is that, 4.7?
Yes.
-1, those are my foci right there. All right, one more, then I'll be done. Any questions on that one? I'm going to go all the way through this one, but maybe just graph. All right, so y plus 1 squared over 8 minus x minus 5 squared equals 1. Yeah, they can really, you can really get some different looks to these, but try to hit a couple of different versions of it along the way here. But yeah, this is in standard form, really, of a hyperbola, isn't it? Because I've got the one side 1, it's got the y squared minus the x squared. So this is in pretty standard form here. So this is a hyperbola. Now the y squared is first, and so what does that mean?
Up or down?
Upper and lower branches. And my center, yeah, so this is where you have to be careful because the H comes off of the X. So isn't this the H right here?
Mhm.
It's the 5, yeah, so it's, be careful and keep those straight. So the center would be positive 5, negative 1. Because this is what's subtracted from the X, so it's the X coordinate. This is what's subtracted from the Y, so it's like. All right. Now, the other thing is, okay, graph-wise, all right, we got this, find the centers. Positive 5, negative 1, so there's my center. All right, so a couple of things. Yeah, this one, I don't know how many they give you that are not nice, perfect squares, but 8, I don't go out 8, and it's under the Y. I don't go out 8, do I? What do I go? Square root of 8, yeah. So I need to go out in the Y, the square root of 8, which is about
2.8.
2.8?
Yep.
Yeah, it's almost. So I would go out 2.8 in the Y, not the 8. I do the square root of 8. So I go 2.8 here, 1, 2, and then 0.8, and then 1, 2, 0.8. And again, that's the first one, but it's under the Y. So that. What about the X?
1.
There's not a number under the X, so yeah, it's understood to be 1. Yes, there's an understood 1 down here, and so you square root 1. Square root 1, you got 1, right? So in the X direction, we go out 1, the negative 1, or both directions 1, however you want to say that. From that center, so there's your little ellipse. Oh, we're doing hyperbola though. Getting way too far ahead of myself here. Try that again. So 1 and 1, 1, 2.8. 8. Yeah, this is hyperbola, so draw the rectangle in that. How do we connect those points? Then draw our diagonals. Upper and lower branches, so upper branch here, get that vertex there, and then get that vertex there. Asymptotes here, so I'd like to see. So there's your vertex points right there. All right.